All right, so today we heard the news that CXC exam is going to be pushed back 2 weeks, but our revision already starts in the channel here, so we are going to start. We're going to continue revision. Today I'm going to do 3 more questions of the booklet that I'm making called the Question Bank that has predictions of questions that are going to come for this year's exam. So these 3 questions are the last questions in the paper in section 2. This section is the toughest questions, right? This section contains relations, functions, and graphs, geometry and trigonometry, vectors and matrices, relations, functions, graphs, and algebra, the 3 that we read in the latest syllabus. So we're starting off here with question 8. Take a look at question 8. I'm going to just bring up the screen larger. And this is one of the crafty ways they can bring quadratic. So very likely you all will face a quadratic, a tough quadratic, maybe completing the square. Something to that extent, or maybe relations, functions, maybe a functions question. There's the chance that a speed time graph or something like that can come for your question 8. Ducking the questions about my haircut and moving into the question, you'll see that we are being asked to find the roots of the equation. And this is one of the, what I like to call a show that question, meaning the answers are there. The answers are there. Now, if you have the calculator that I provided, that I told you all to use, you'll be able to verify this answer very quickly. You could put this in your calculator and you'll get that answer. But this question is crafty. For the 3 marks, they're giving you the answer and they want you to tell them what it's going to be. Now, there are a number of people in the live saying that it's blurred. If it's blurred, it's a you problem. So what you need to do is click on somewhere lower here in the video. You'll see the gearbox. Click on that, and I am shooting this out at 1080p. So for some reason, when it comes from Streamlab, YouTube likes to set it at a low setting. So why isn't the chat if you've seen it perfectly fine? So you'll realize some people get it at the high setting. You just need to change the setting. If they detect your internet connection low, they wouldn't send you the HD. All right, so anybody know how to do this? Why isn't the chat if you know how to do this? This is a show that question. So you need to take this and express it like this. So there are 2 ways that I'm seeing that students may choose to do this. One is completing the square, which is the long route, which is if you are accustomed to this completing the square. If you are accustomed to completing the square and you know that this question 8 is usually completing the square, you'll probably run down that one time. That's fine, but that's more like 4 marks of working for CXC. I believe the fastest way to do this is what? What would you do? The fastest way to do this, I believe, is the quadratic formula. For a CSEC student, the easiest way to do this is the quadratic formula. And you should have that quadratic formula in your back pocket. You just know that like that. So what is the quadratic formula? Quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. If you have the quadratic in the form ax squared plus bx plus c, where a, b, and c are the coefficients of x squared, x, and x to the power of 0, meaning no x, respectively. So in this equation, what we have is 25 x squared minus 30x plus 7. Can you all tell me the values of a, b, and c in this equation? What are the values of a, b, and c? So you should be looking at that and you should be seeing. Good evening to everyone from, just shout out your country, let me see where we're getting people from. Feel free to close off the live chat, press like on the video, feel free to share it with your peeps and say we're studying today. We're ignoring all the exciting and life-changing news that we heard from CXC recently. So I'm seeing A is 25, negative 30, and 7. People keep telling me, so turn your this on silent, turn your that on silent. Let me just try and obey a little bit here. So we'll have x is equal to minus b, so that's negative 30, plus or minus the square root of b squared, which is negative 30 squared, minus 4 by 25 by 7. And then we're going to divide this by 2 by 25 for this equation using these coefficients here, these coefficient values. And we just substitute in as we go there. Why isn't it chat if everything looking nice and sweet? No problems. So here's a nice place to just let your calculator do the talking. 30 squared is 900. Negative 30 to begin with is just 30. What we're looking to get? We're looking to get x is equal to 1/5. This is going to be really interesting. Let's just keep working out with this. This is what we're looking to get, right? This is a lovely question, if I must say so myself. So 30 plus or minus the square root of 900 minus 4 by 25 is 100 minus 700. So it's working out nice. This is just niceness divided by 50. I just see niceness in the camp here. Yeah, so one of the reasons I took this haircut is so that while I started doing the YouTube lives, the glare from my head would help you to not focus on this screen and yet focus on that screen there, right? So 30 plus or minus the square root of 200 divided by 50. I am getting so far. There are different ways to. You could probably just jump to the answer there one time, but I won't do that if I were you. Yeah, this from your calculator, you could just jump to the answer there. But I'm seeing here so far that this is looking like 3/5. If I separate it, 3/5. Yeah, 3/5 plus or minus, because I just cancel these zeros now. 30 over 50 is 3/5. Plus or minus the square root of 200. Now, especially AdMath students would know there's something called surds, where we could say the square root of 200 is the same as the square root of 2 times 100, which is the same as the square root of 2 multiplied by the square root of 100. Now, your calculator will be able to do this and come at the finish line here for you, which is the same as 10 over the square root of 2. 10 times the square root of 2. Take that in. Take that in. Feel confident about that. Let us soak in your bones. That should make sense to you, right? The square root of 200, you could just separate it in a product, and then you could separate the square roots like that. That's legal. In case you didn't know, that's legal. That's allowed. We're allowed to do that. And at the end of the day, we'll have 10 over the square root of 2 over the square root of 50 over 50. Don't forget the 50. We had the 50 there. So this is like saying 3/5 plus or minus 1/5. Instead of 1/5, I could just put root 2 on 5. Look at it, love it, accept it. Everything looking good there. Why isn't it chat if anybody have any complaints? Now this is a very easy question for an AdMath student or a student who proficient in mathematics, but it can be a very troublesome question because of the square root. If you just just normal in maths, or maybe on the fighting upside of maths, then you wanna squeeze out this 1/5, because that's what you're trying to prove. The question is saying to prove that. So I could squeeze out the 1/5 here and see that this should just give me 3 plus or minus the square root of 2, and I'll collect my 3 marks. So this was like the fastest way to go ahead and do this, and you should be able to run through this rapidly. From the time you reach here, you can just plug that in your calculator and see that you're getting that. So you could kind of even bluff your way through, right? So there's something that I want to teach you all, as one person just mentioned it there. I do a lot of classes, and I've helped a lot of people. And one of the things that I look for, I'm very obsessed with, is what gets people to do good and why some people are doing bad. And one of the things I notice is that students who are on the rise, or students who are going from bad to good, students who are getting better and better, or top students, they ask excellent questions. They ask excellent questions. So they ask, where did this come from? So why is this 10 times root 2? They ask specific questions. Students who struggle with maths ask questions like, so you can repeat everything there? So I don't understand. Why you don't understand everything? So if you know that is you, if you know that is you have to find a way to ask specific questions. I know I'm telling you, it will help you to even if you're in Form 4, Form 3, you're watching this video in the future. I'm taking the time to say this. When you're in class and a teacher, you start to see like you're getting lost, ask a question one time, a specific question. Most maths teachers who teach maths, somewhere in the past, even if they turn into a grumpy, strict teacher, somewhere in the past, they loved mathematics. They love explaining certain things. So if you could ask them a specific question, if you ask me a specific question, that's my strong point. I love to explain. If you ask me to repeat the whole thing, I will tell you this is going to be saved on YouTube, and you can just pull back in the beginning and watch over the whole thing for yourself. You don't need me to repeat the whole thing as a video. You can repeat the whole thing, right? So, all right, let me keep moving. Hence, otherwise, solve this. Another tricky thing, we already established that indeed the roots of this is this. Now, what does roots mean? Roots mean like you have a quadratic, the x values when y is equal to 0. That's the roots, right? We established the roots. This is something abstract looking. Math students shouldn't have a problem with this, as I said, but it could be a little abstract looking for, meaning weird looking for CSEC students. But it's like we get two values for x, like 1 and 2. It didn't look in so, but it's like we did that. So like 1 and 2, we got two values for x, right? So they're saying hence otherwise solve this simultaneous equation. So I am immediately thinking that I am going to, when this is a linear equation, this is a nonlinear equation, I'm thinking that immediately, nonlinear, because you see the two variables multiplying by each other. It's not the simultaneous equation where you're solving via elimination. Go and look up my videos on simultaneous equation. This is the tougher version where there's a linear equation and a nonlinear equation, and you need to substitute for y in this. And I am immediately thinking that I would form this quadratic, and then I would be able to assume the answers for x immediately. So if you are not seeing the screen properly, you need to change the quality of your video. There's a kind of gearbox thing. You click on that and you'll be able to pick the resolution, 1080p. Anybody who come and mention that, just let them know in the chat, right? So that's what we're going to do. So let me just write over this, and y is equal to 5x minus 6, and 5xy is equal to negative 7, and we'll go and have some fun with that on a clean page. One of the worst things in maths, is to be in your book doing a question on this page, and you reach here and you have to go on to the next page, and you have to be like, that's one of the worst things that could happen to maths. Anyhow, so we have y is equal to 5x minus 6. We're going to substitute y is equal to 5x minus 6 in equation 2. So we do have an equation 2, so let's make one, equation 2. Ta-da! Right, so in equation 2, we're going to be like 5x by 5x minus 6 is equal to negative 7. I'm going to get 25x squared. You all seen that 25x squared coming in there? Like some good homemade ice cream. When you do that distribution, 5x by 5x is 25x squared. And 5x by negative 6 is negative 30x, if I must say so myself. Bring across the negative 7 one time because we're very happy. So that's going to be plus 7 equals 0. Now we need to compare this to this. It's the same thing. It is the same thing. So therefore we know from part 1 or A or whatever the part was called, from part I, sometimes in my class, like people reading out, and they will say part I. That's the weird. That's one of the weirdest things I ever hear. So, and this is 2, Roman numerals 2, but some part I. Anyhow, from part I, you have x going. You know the values of x. X is either going to be 1/3. Let's put the whole thing. What it was, 3 plus or minus the root 2. Was it that? Yeah, 3 plus or minus the square root of 2. That's right, Dinel. He said the worst thing is doing a whole maths or add maths exam in radians, and you're supposed to be in degrees, or if you're in degrees and you're supposed to be in radians. If the screen is blurry for you all, you need to change the quality, right? I'm streaming at 1080p. Somehow YouTube will need doing that and lowering the quality of people's videos. You just need to change it back up. All right, so let's just quickly recap what happened here. From the first part, we know this. We know that if we see this equation, this is the answer. This is two answers for x, actually. I'll show you just now. And then the second part is this. We need to solve this equation, which is a simultaneous equation. So what I did is substitute the 5x minus 6 into this equation for y. You all agree with me? Everybody good? Everybody calm? Into this. So when that happened, it went here, right? And when we expanded, alas, we got this. So therefore, values of x, and they said to solve what this is. They solve, so you could put values of x is equal to, you could get the decimal if you want. 1/3. Was it 1/3 by a third or 1/3 by 1/5? I put 1/3. Anybody pointed out? Thank you, Zara. 1/5. It was 1/5. 1/5. So x1, we could call it like x1 is 1/5 by 3 plus leave all these thing, and then x2 would be like 1/5. You understand what happening here? By 3 and minus. So you separate them. So that's why you get the 2x values. That's why you get the 2x values. So x1 is, you all can give me that to some kind of decimal place. In maths, you can feel free to use a decimal and substitute it back in one of the equations. Yeah. And at maths, I would just say use this and put that in there and have fun. I might show you how to just substitute this whole thing into that. But keep in mind, if you're struggling in maths, this is a really tough question. If you're good at maths, then you should be able to see a way. So that's x1, that's x2. Somebody could give me the decimal equivalent of x1 and x2, and then y would be 5 by 1/5 by 3 plus root 2 minus 6. That's y1 to come that is compatible with x1, and y2 would be 5 by the same 1/5, 3 minus root 2 this time, negative this time, right? So this works out to be -3 plus root 2. You could verify that for me. And this one would work out to be, I should have a -6 in here somewhere. This one would work out to be same -3, but minus root 2. All right. How much marks are we looking at for this question? And somebody saying the values, one is 1.41 and one is 14.1. Y'all can just verify these values for me here. We look at it in the answers just now. Just put in your calculator and get those values, because there are root 2 involved. So this is how to do this question. Definitely, if you was lost here, save this video, come back and try it out. Definitely, if you was lost. How I get the values for y? I took the x value and I put it back, just like a simultaneous equation. I substituted it back here. So that's what's going on here. That's what's going on there. And then you solve. Or you could work out this, and let me say you got 10, you wouldn't get 10. You just put the 10 here. You just put back the 10 here. You get some decimal. So somebody's saying x2 is 0.3. I'm going to go on to the next question. Don't worry, I'm seeing the comments that some people lost. And as I said, this is one of the challenging questions. 3 plus, what is it, root 2? This is going to give me, I'm getting 0.88. You all got that? 0.88. Yeah, 0.88. Let's make it 3 decimal places. And then for this one, we'll put 0.3. Instead of 2, I'll put 17, 3 decimal places. And for this one, you should get -3 plus root 2. negative 1.59, and with this one you will get negative 4.41. So y'all can verify those answers. If there's any mistake or anything, I'll just verify any comments after I post the video. Or we'll go and check the answers now. You can leave it with the roots. Let's go on to the next question. So consider the function y is equal to 2x minus 3. Now, this is, as I said, this was a really tough question. Pay attention to this question. This is like one of the toughest things that could come for a CSEC Maths exam. I just do it just now. Go back and watch our video, vibes it. Consider the function. We have this function, y is equal to 2x minus 3. We need to fill in the blanks. This is form 1 thing. This is easy man thing. So you just need to plug in values here. Complete the table. That's why they're only going to give you 1 mark. They only give you 1 mark. So why is in the chat if this back to reality? If you understand how to do this, this should be easy for everybody. Don't forget to close off the chat and press like so more people can see the live. So we want to substitute negative 1 in this, and then we want to substitute 4 in this. Let's just do the working. It's simple, but still let's do the working. I'll do it in red. So it would be like when x is equal to negative 1, y is equal to 2 by negative 1 minus 3. So you'll get negative 2 minus 3 is equal to negative 5. So you put that in there. Why is in the chat if you're all okay with that? Nice. So everybody good. And then we're going to put 2 into this the same way. We get 2 by 2 is 4 minus 1 minus 3 is 1. And we can see that that kind of pattern is always happening with these things. So complete the table above for the missing values. We did that. We gave you 1 mark. Draw the graph. Here comes these graphs again. Draw the graph of y is equal to 2x minus 3 using a scale of 2 centimeters. I know my thing is landscape. Your paper in the exam will be portrait. So my scale will be a little different, right? Using the graph drawn, determine the value of x for which. So what I noticed CXC doing these days, pay attention to this. What I noticed CXC doing these days is that they're giving you the graph. They're giving you they're not giving you the graph drawn, but they're giving you the grid. So like you'd see a paper with a grid in it, and maybe the axis already put in, and you just need to come and draw the graph now. The reason they're doing that is to speed up the process, so that they don't have 1 star marks lost in just you drawing graph and that kind of thing. Because it used to be out of 120 marks, now the maths exam is out of 100 marks. All right, so if we had to draw this graph, what we're gonna do, boy, we had to go from negative 1. This is what I do. Like we had to go from negative 1 to 4. So I keep in mind. So it's like negative 1 to 4, negative 1 to 4 here. That's what's in my mind. And the lowest we go in is negative 5, and the highest we go in is 5. So we're going kind of equal down and equal up. So I would ideally put this graph in the middle. Y'all with me? I'd put this graph in the middle somewhere about there. So bang, and like this. So not like that. Not like that at all. Like this. Right. So those are my 2 axes. My battery was dead when I was starting, and that is why it takes so long. I was waiting for this thing to charge. Drawing these graphs, boy, oh gosh, why? So what we're going up to? We're going up to 4. Let's say I use 1, 2, 3, 4. That's too small. That's too small. Let's use double. Just to really drive the point home here now, boy. So this might be like 0. This would be negative 1. It should really be like about there. So this would be 1, 2, 3, 4. That looks good. 1, 2, 3, 4, 5. All right. 1, 2, 3, 4, 5. Now this graph may not look like the graph that really supposed to happen because the scale different. That's what I'm saying, right? But everybody okay with this? You understand what's happening here? You understand what I'm doing? So you really just need 2 points. Negative 1, negative 5 was 1 point. And then I think 4, 5 was the other point. So once I connect these 2 points nicely, like that, that's the equation of that's the line. But if you had all these points, I would suggest that you include these points to make the thing look good. So 0, -3. We had 1, -1. We had 2, 1, and we had 3, 3. I believe was a point 3, 3. Yeah, 3, 3. So we good there. So somebody asked him if I could keep a Zoom class. Y'all, I don't know if people watch this in the future, so I might as well say it. I have classes in maths. People here from my class add maths, physics. These are the classes I teach: pure maths and lower school. If you go on Instagram and you search for something called the Student Hub, that's my online school, the Student Hub. And 7840619, if you're from a different country, +1 868. We have students from all over the Caribbean in this. So if you don't know about this, well, now you know. I feel like everybody is know, but everybody don't know. So, and you can sign up to do classes at the Student Hub. Now, we don't only have this. These are just the classes that I teach. We have nearly all CSEC and CAPE subjects. And we have lower school options too, lower secondary. And we have SCA. That's the common entrance for Trinidad. Now, if you're looking for some free resources, just go on the Student Hub on the Instagram, the Student Hub on the Instagram page, and click the link in the bio. And when you click the link in the bio, you'll be taken to the promised land. Anybody know what I'm talking about? Just trust me on that one. That's what I was saying. I can tell you, in the promised land there, last time I checked, 14,000 students on that. So good luck. So we completed the graph, draw the graph. We did that. Using the graph drawn, determine the value of x for which 2x minus 3 is equal to 2.2. So this is literally replacing the y. So when is y 2.2? And yes, they say using the graph. I love that. So when is y 2.2? You'll be like 2.2 is over about there. So on our graph, you'd use a little dotted line. Y'all familiar with this trick? You kind of have a dotted line kind of vibe. Let me make we line dotted now, boy. You have a dotted line vibe going across there. Bang! It hit the line that you want. And then it come down like that. Bang. You're not supposed to go below the axis. I just wasn't getting it to stick. So that there is the point of interest that we're looking at. So to me, this looking like 2.5, 2.6. Looking like I got 2.6 there. So the answer we want for this question here is 2.6. You all agree with that? Why is in the chat if everybody agree with that? So that takes us to the end of this question. So I'm going to scroll down. This is page 58. I'm going to scroll down to the answers. You all remember we were doing this on Sunday? Anybody was in the Sunday live? What am I looking for? Looking for question 8. In question 8, we did this whole long quadratic formula thing. We got that. We got the roots. We substituted the roots in here, and we got the y's. So we got the x and we got the y's, and that's the end of that. Now you can put this in decimals if you're feeling happy, but this is taken as is as well. You substitute here, good. We got -5 and 1. You draw the line. This is how your line would look really good. This is how your line would look with the proper scale. And then you do the 2 thing, and you get 2.6. 2.6. X is equal to 2.6. And you put by reader or from according to graph or whatever. Nice. So let's go on to the next question. That's page 109. Keep that in mind. 59. Page 59. So we're here facing question 9. This is some good stuff. See this here? This is some good stuff. The diagram below, not drawn to scale, shows a circle where 2 lines intersect, blah, 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 blah. All right. Determine given a reason for your answer. Notice, say something about a right angle here. Note that triangle BDE is a right angle triangle. Wow, this is not drawn to scale at all. This is drawn to, oh, okay. This is the right angle here, but still not drawn to scale at all. All right, so if this is a right angle, this kind of suggesting something going on here. You know, it's suggesting a little suggestion. Anyhow, so and BD is the diameter. Okay, so you didn't need to say anything. Yeah, you didn't need to figure it out. BD is the diameter. So because this is the diameter, this has to be right angle. So they really and truly didn't need to say that this is a right angle triangle. They could have just said BD is the diameter. Anyhow, so determine giving a reason for your answer. BCE. BCE. What is BCE? This is samples. What? Quit. BCE. So BCE is this angle here. What is that angle? Like 3 marks, the angle is 102. And you state that this is 102 because of angles on a straight line. Angles on a straight line equal to 180 degrees. Therefore, BCE is equal to 180 minus 78 is equal to 102, right? Easy man thing. All right, next one, BDE. What about BDE? Well done, Dinel. So that's good. BDE. Keeping in mind that we already know this angle here. So we're looking for BDE. Well, yes, BDE is also 66 degrees because what we call the Bonnier's thing. And BDE is equal to 66 degrees. Let me see if anybody have it. I never see these past paper questions. These are sample questions in Justice. BDE is 66 since Denel has it down cork, since angles from a common chord from the same segment are the same, right? So there's a common chord here. So the only thing I would do with Denel's working, I would say angles from a common chord, and you would name the chord BE in the same segment are the same, are equal. So you would say that BAE is actually equal to BDE. And finally, we need to find DBE, this angle here, DBE, this angle over here. So, well, that's easy. This is 90 degrees, this is 66. Angles in a triangle equal 180 degrees. And so 180 degrees, therefore what were you looking for? DBE. Well, I can't just write what I was saying for, but DBE is equal to 180 minus the 66 plus the 90 that we have, and everybody is saying that's 24 degrees, and I believe them. So this was a very easy one. There were 3 really challenging questions that I placed on my Instagram that I want to bring up now, and then we're going to go on. We'll determine if people had the right answers for these questions. So on my Instagram, there's this one. What is the size of angle X here? So can anybody tell me what the size of angle X is? So this one was really interesting. Now, a lot of people was doing the cyclic quadrilateral thing, but the cyclic quadrilateral is for a cyclic quadrilateral. A cyclic quadrilateral is something that you have the circle and there's a quadrilateral actually in the circle, circumscribed in the circle. So to find this, what did we do? Anybody have any idea what X is going to be equal to? Remember, anyone can become a pro at circle theorems if they do enough questions. So here's me going at this question now. This is a tangent. The angle between a tangent, this is called the alternate segment theorem. This angle that I'm going to write here, this angle there. Let me get something a little more bright, boy. This angle, oh gosh. This angle here, this angle is actually 68 degrees as well. That just solved the entire question for you, right? And that just solved the entire question for you. If this is 68, well, this must be 68. But there are two rules that you need to state here. One is the alternate segment theorem. It says that between a tangent and a chord, this angle is equal to the angle in the alternate segment. And I have videos on circle theorem where you can see that listed out. So that's one. And this is a really tricky one, right? So go on my page after this and see if you can remember, and you can do it for yourself. And then, since this is 68, this angle must be the same. Now, why is that angle the same? You need to state the next rule. The next rule is saying that from a point on a circle, the two tangents would make an isosceles triangle. That is a circle theorem. That's one of that's the least remembered circle theorem. So from a point outside a circle, the two tangents form an isosceles triangle, and the base angles in an isosceles triangle are equal. So you must state those two rules, otherwise you don't get a mark for this one. And once you get the 68 here, well, you could see a way, right? So 68 plus 68, 136, and then you subtract, and you get 44 degrees for x when you add up the whole triangle. This was a really good question. And we see a lot of people wasn't getting it out, but some people got it out. Some people wasn't getting it out. And this was done poorly. Normally you have like 30, 40, 50, 60 answers. I only see like 9 answers. Here's another one. This one is really simple. Isabella was wrong. Go on, go message her and tell her. Message her and tell her. Yeah, so this is another simple one. Well, this is the same thing that Daniel said earlier. Comes from a common chord. Now, what they do in CXC sometimes is the same thing. You're not seeing the chord, but it's there. There's a common chord there. So this angle must be equal to that angle, right? That's one of the easy ones. And lastly, this one, they wanted BCA. So BCA, angle BCA, what is angle BCA here? What is that angle? This angle over here. Anybody have any? Why is in the chat if you have any ideas how to figure out that angle? It's a little small. Let me see if I can zoom in a little bit. Oof, it's not really doing it that good. BCA. All right, what are you all thinking of? All right, so this is how I would solve this question. I know this is 110, so therefore, what's this size? If this is 110, this must be 55, right? So that's one rule there I activated. The angle at the center is twice the angle at the circumference. And if this is 70, the same alternate segmenting, this must be 70 as well, right? So another really tough, and once you find two angles in a triangle, I mean, finding the other angle is no problem. Why is in the chat if you understand? So the next angle for sure here is 55. Yep, 55. Well done. Well done, Navin Peter Judlin. All right, so let's continue with our questions. This is a bearings question. It's going for 6 marks, so it's probably gonna get interesting. What is one of the things you normally do in bearing? Cosine rule, sine rule. So let's have a go at this. Let A, B, and C be 3 flat poles. The bearing of A from B, right? So watch the one that they say from B. So this is 45. The bearing of C from A is 140. Lovely. AB is 12. AC is 5. Find the length of BC. Lovely, 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 lovely. So how are we going to find the length of BC? Wait. This are nothing. That's 3 marks. It's 3 marks. But it's just 3 marks, boy. I hope it work out. I hope this work out well, because it kind of like a teacher could set this question and actually put the wrong numbers. So yes, this is 13 because it's a 5, 12, 13 triangle, and you can use Pythagoras theorem to prove it. Where you have c squared is equal to a squared plus b squared, and this is c, this is a, this is a b. C squared is equal to 12 squared plus 5 squared, 144 plus 25, 169. That's c squared. So c is equal to plus or minus the square root of 169. Well, since you're dealing with lengths, you know you only do the plus part. So this is 13 centimeters. So that one is easy. That is you get 2 marks for that. Nice. Determine the value of angle x. Angle x here. So when we determine the value of angle x, it's going to be very simple for us to do that. One of the tips that I suggest to my class in bearings that really works for students is to lengthen these lines, these north lines. Just lengthen them when you're dealing with the question. It's help you to see. You all know about this? That this angle is equal to that angle corresponding, or vertically opposite angles, or co-interior angles. You know the rules surrounding those, or what you call these? What you call these? Alternate angles. Yeah. So what's happening here? We can determine that this angle is 40, right? Everybody see now, we can determine that that angle is 40 because it would form a 180 degrees. And you need to state all of that information here, right? And if this is 40, alternate angles are equal. The north poles, that north line would form parallel lines. Somebody's asking to, let's say, saying remind us of the rules. I'm just going to remind you of the rules very quickly just now. So this is an alternate angle. This line is called the transversal. So it's cut into parallel lines. So it means that this angle must also be equal to that. So this is 40 degrees, right? Write out your reason. Just to remind you very quickly of these rules. If you have two pairs of parallel lines like this, let's just make the lines parallel. 2 pairs of parallel lines, and you cut it with something we could call a transversal. It doesn't matter. You just cut it anyway. This angle here is equal to this angle here. You call those corresponding. So this one, the orange, that's corresponding. If I do a setup like this, now you can have different corresponding, like this is corresponding to that, so that'll be equal. But if I do a setup like this one here with this one there, with the green, that you call that alternate. You get the vibe, it alternating. Now, if I did a setup like this, blue, you all see those colors, right? The blue and back to the orange. So the blue and the orange, this orange here, as a matter of fact, let me darken him. That orange, we call those co-interior. And co-interior angles add up to 180 degrees. Co-interior. So this angle and this angle, when you add that up, you must get 180 degrees. What else am I missing? I'm missing this. If I have these 2 angles here, we call those vertically opposite. And they are the same. So corresponding angles are equal, alternate angles are equal, vertically opposite angles are equal, and co-interior angles, they add up to 180 degrees. That's the rules in a nutshell there. And you must know those rules for CSEC. One of them rules they gonna get tested in your exam 2 weeks later than the exam date originally was, right? Calculate the bearing of B from C. So the bearing of B from C is this angle. We need to find out about this angle. To find out about this angle, there are lots of things that we can do. So many different ways we could get the answer here, which is why I'm concerned that this question may have an error in it. But we'll see. I'll check the answers, right? So one of the ways that we can solve this, I'm just going to go ahead and do it, is by understanding that we know this angle. And we want the bearing of B from C. That's not this. from C mean we need to check with C, talking about C. So we start at C and we get the bearing, meaning you start at north and you go clockwise. We want this angle. Well, what I'm thinking about to get this angle here is to add the 40 and add this angle. They might say, I don't know this angle, and you would be right. But I could find that angle very easily. What's one of the ways I can find that angle? So why am I trying to get these two angles? Because once I get these two angles, I just subtract from let's call this thing. I subtract from 360 degrees. The whole thing is 360 degrees. So what I'm saying is one of the ways I can get this angle here is that yes, I could use the sine rule, but I feel like the easiest way is to use tan. You understand what I'm saying? Let's call this angle X. It's really ACB. So I might use ACB in the exam. So let me say that angle ACB, the tan of angle ACB, or let's put ACB equal theta. The tan of theta is opposite over adjacent because it's a right angle triangle. Normally in these questions, you don't get right angle triangle. This angle is be some kind of obtuse angle. Look sharp, you get a reflex angle, all kind of thing. So having a 90 degrees here is a blessing from above. So if there's a 90-degree angle, you could use SOHCAHTOA. Right angles are the only thing you could use SOHCAHTOA and the Pythagoras theorem on. If it's just a normal triangle, you cannot keep that in mind. SOHCAHTOA and Pythag. Why a freeze, boy? Pythag, right? That is for short. Pythagoras theorem. You can only use those on right angle triangle. You can't use SOHCAHTOA and Pythagoras theorem on like triangles that are scaly, not right angle. Not right angle, I should say. So opposite over adjacent, let's say 5 over, opposite will be 12. 12 over 5. So theta is equal to the tan inverse of 12 over 5, which is how much? If I'm to believe Ariane, this is 67.4 degrees. Not 90, it's 85. What's not 90? This, in practice, when you check through everything, it's not 90, it's 85. What's that, Ja Eddie? Anyhow, so we're using the tan, we get 60. Some people want me to use the sine rule. Yeah, you could use the sine rule. What they wanted? No, they want to calculate the bearings. If you use the sine rule, you could use the sine rule to get the angle here, but it's extra long. It's a right angle triangle. You could just use tan. You agree? Why isn't the chat of everybody good? I've seen some contention in the chat from Abhishek, Kumar Gupta, and Monish. Now, if somebody asks, is it a right angle? Can't use the sine, cosine. You could. If I use the sine and cosine, I'm supposed to get this, The sine and cosine are like tanks. Those are the heavy machinery. We only bring in those two big formula. We only bring in those two big formulae for like if we don't have a right angle. But you could use them on a right angle, but it's like you're overdoing it. Like just use tan or SOHCAHTOA or whatever, right? Josiah, I see a comment, but I don't want to call people's school name in this chat like that. So we get 67.4. So the bearing is going to be easy to find out. The bearing of B from C is going to be 360 degrees, which is the whole thing, minus the 40 plus the 67.4, which we just got. And what's that answer? I feel then I'll have it cooking there. Or somebody have it cooking. Oh, Deja. That's looking a little suspicious. That looking sus. 252.6 is great degrees. Nice. So that's it there. So you get your full marks. Now we're gonna go down to page, what was it? Was it page 109? And we'll see the angles that we got: 102, 66, and 24, which was correct. And Pythagoras theorem, you get 13, or you can just understand 5, 12, 13 triangle very quickly. You get this 40, 40 alternate angles, alternate angles, whatever you want to use. Alternate angle seems best. And you get this angle to be 67.4. There it is. Use stand, that's the fastest thing. 1 decimal place standard. And you subtract the 40 and the 64 to get the entire angle here. And that's 252.6. Some of these angle lines looking really ridiculous. All right, so let's go back up. We have one last question to do, people, and then I'll let it bust out. What the question though? Oh, I'm supposed to be on 59, not 89. All right, so that was that. Let's go on to question 10. We're going to do some matrices and vectors. If you're seeing it fuzzy, you need to change your camera settings, right? Today's press conference. CXC Spy, you need most these days. This CXC Spy profile out here a long time, like since like about 2 or 3 years. This CXC Spy profile, I'm telling you, this CXC Spy profile used to be fighting me down right through. For real kind of fighting me down. And now the man on my side, like you give up your work at CXC, boy, too much bacchanal, boy. Let A be this and B be that. Find the product of A and B. So I guess we'll have to have M and N being left in the product. So A is equal to M 1, negative 1, 2, and B is equal to negative 3N. Samantha, I'm just gonna set you as a mud here. Wait, how I do this again, man? I thought I would be able to do it. Like I can't do it because I need some more mods. When on YouTube, I'll see if I could organize that. Where am I? So I said B, A and B, and I just want to multiply the two of them. I mean, you never see me and Lacazette in the same room together. Just saying. And find the product of A and B. Now, there's only one way you can multiply these type of matrices. The only way you can multiply them is by putting the 2 by 2 first, and then putting the 2 by 1 after. If you try to do the other way around, you'll get error. Can't. And you can take a look at my video on matrix multiplication to see why. All right, so let's get this done. M1, negative 1, 2. Everybody paying attention? So you multiply this by this, and then you multiply this by this. So it looks like negative 3M plus negative 3. What am I saying? Negative 3M. Yeah, that's a M. I said M, right? Plus 1 by N. So that's just N. And then you'll have 3 plus 2N. This by this plus this by this. So a lot of you all saying things that you don't need to do. You don't need to reinvent the wheel. There's the Discord channel. You just go on the Discord channel and all will be revealed. Somebody can send the Discord channel link. He is a private class. That's true. You could go and register to the private class. So you can just follow me on Instagram and you'll see all my information there at Cohen Springer, right? So all the questions you have, just follow me there. You could DM me. For the last year. I'm not exaggerating for clout, as you to say, but I get like sometimes 100 messages every day, and I answer all the messages get answered. So you can DM me, even if you have a message now from 2-3 days ago. Don't worry, it's answer in bulk. Go through in bulk and answer, so you'll get answered. All right. So this is the multiplication. That is it. That's what you wanted, right? So that's the answer there. Find the product of You have negative 3m. Everybody agree that? Negative 3m plus 1 by n. All right, so yeah, so negative 3m plus n, and then 3 plus 2n. I feel like that good. Once I make no transcription errors, everything looking good here. Find the values of m and n such that when we multiply this, we get this. So what they're saying is that the answer that I got is now equal to something, and find the answer. That's lovely. And it's not even a simultaneous equation in itself, really, because this one only has one variable in it. So we could find m and then substitute it back and find m. Are you with me? Everybody with me? So when you multiply this, you got that. When you multiplied a by b, I got this as the answer. That's the product. And now they are saying that the answer is equal to this. So what I can do is say this must be equal to that, and this must be equal to that. Let's go on a new page. Fortunately for me, page endless is digital. Benefits of digital, boy. So using this one first, I can say 3 plus 2n is equal to 9. This means 2n is equal to 6 when I bring across the 3, which means n is equal to 3. Well done, Ariane. Ariane working at a rapid speed here, and this is never seen before papers, and this is sample papers. So negative 3m plus n is equal to negative 9, and since we just find what n is, I left out a line here that I feel like some people may not appreciate. I'm just waiting. It's get really lazy as a math teacher sometime, and I just be skipping out things like black is white. Negative 9 minus 3. So you get negative 12, negative 3m, and m is indeed 4. Excellent work, Shivam, Jakim, Pierce, Joshel, all of those. So you get negative 12 divided by negative 3 is equal to 4. So what they wanted, the values of m and n. So we got the values of m, we got the values of n. One was what? One was 3 and one was 4. It's not 3 and 4. Wow. Solve the following pair of simultaneous equations using the matrix method. So this is lovely. You all get to see this entire operation in effect. There's a way to do this on the calculator that I recommend as well. I wonder if I'll have time to show all that, if I have energy to show all that. Just now I get a call from Luvia saying, what are you really doing? Time to come home. Forget them kids. Let them suffer. My wife, so 4, negative 5, 4, 3, x, y equals 17, 9. What I did there is rewrite it in the, and you can always look up this video, this is called matrices, simultaneous matrices, or solving simultaneous equations using matrices. You can look for that on YouTube, search with my name and you'll get good things. Rewrite. Sometimes I fight up with R's, like if I can say it, but rewrite in matrix form. So the whole aim in this is that you want to bring this across and you want to use the inverse of this. Because in matrices, when you bring something over, you just get the inverse matrix, right? So the inverse of that multiplied. That's the idea. That's the idea. It's like you have A by X is equal to B. So therefore, A by A inverse, or sometimes they have Y. But let's put B, not to confuse it. A inverse by X is equal to A inverse B. So this is something that I tell my students to take a little write with. Just like memorize this off. A inverse by B. So X is equal to A inverse by B. It might look confusing if you never see it before. It's something simple. This is really saying, let me show you what they're saying. Let me show you what they're saying. This is really saying like 3 times 3x is equal to, let's just put 6. So therefore, 3 multiplied by 1 over 3, x is equal to 1 over 3 by 6. You all understand what I'm bringing out here? So 1 over 3 3 multiplied by 1 over 3 is 1x. 1x is equal to 1/3 times 6 is, well, the answer. I'll just leave it as 1/3 times 6 so it will look like this. This is what is happening in matrices. This is what is happening in matrices. When you multiply by the inverse matrix, it's like you cancel off on this side. So you get the identity matrix. And the identity matrix by anything is the thing. And if you multiply by the inverse matrix on this side, you also need to multiply by the inverse matrix on this side. So what you can do is just memorize this and throw this in as like a little theory when you're doing your simultaneous equations. Back to the simultaneous equation. So the aim now in our life with the simultaneous equation, and this is 3 marks, you need to be like gunning through this question. Is a simple question and you need to practice a lot, is find the inverse of this. That's the matrix, right? So you're finding the inverse of that. So what we will do to find the inverse is we'll first find the adjoint. So it's in the form, this is in the form A, B, C, D. The adjoint is the same as swap the D and the A and change the sign on B and C. So the adjoint is going to be 5, -4. That's going to come here. But instead of putting that 4 there, I should send him here and send the 3 there. That's how the adjoint would look. And the determinant is AD minus BC. One of the tricks that I use is this line must line up to that line. So this is the diagonals, is the product, and then you subtract the diagonals, right? So you're gonna get 3 by 4 minus 5 by -4. So you get 12 plus 20. So you get a high number, 32. All right, so the inverse, now when you're finding, after you found the adjoint, after you find the determinant, you find the inverse. So the inverse is 1 over the determinant by the adjoint. This is the same as 1 over 32 by 3, -4, 5, 4. Now I'm not going to put this 1 over 32 into all of them. I could just divide everything by 32. The 4s will do nicely, and you'll get like -1 over 7. 8 and 1 over 8. Somebody from across the world saying it's 4 in the morning. Right now, you know, it's the time 6:36 p.m. in Trinidad. This is the Caribbean. This is Trinidad, the home of Brian Lara and Dwayne Bravo. All right, so 1 over 32, 3, 5, -4, 5. We could just leave this like this and see what's cooking. We need to multiply by 17 and 9. So therefore, the xy is going to be the inverse, which you just found to be 1 over 1 over 32. Somebody got the answer. Is 6 and 30. 1 over 32 by, who got that answer? Is it Monish? 3, 5, -4, multiplied by, what was the number? 79. Now I don't want weak students to get lost, or you get 3 and 1. So different. So what happened here? This is the inverse that I just found. Remember? So I'm putting the inverse, and this is the column matrix that was on the end right here. Remember, we got this and we brought it across and we found the inverse. When I got the inverse, this is what I got. Now, as I said, I could put 1 over 32 and just divide everything by 32, but I choose to leave the 32 on the outside. Yeah. So let's go. So this will be 1 over 32 multiply 3 by 17. How much you get? Again, 51 plus 5 by 9. Why am I getting these big numbers? All right, it's working out nicely. Yeah, that's going to be 3. And -4 by 17, and then 4 by 9. Speedy Eaton. Speedy Ethan, I think you may have a mistake, bro. Yeah, I think you may have a mistake. So you have here negative 68. We want on decimals plus 4 by 9 was this 36. I'm getting 1 over 32. I'm getting 96 here. So 32 into this gives me 3. And this one, negative 68 plus 36 is giving me negative 32, which is working out nicely. You see why I leave the 1 over 32 outside? It would just complicate this with fractions. And up to now, you can do everything here in your mind and just double check with it on the calculator. So in the end, this is going to work out really nicely to be like 96 divided by 32 and negative 32 divided by 32. You understand? So you're going to get 3 and negative 1. And we just have one more question to do and we'll be over. So the value of x is 3 and the value of y is negative 1. Take a look at this question, write it down and do it for yourself after. And then come back and check back the working. Well done, Ariane. So let's just do the last question now. That's lovely. So this is a classic example. And if you don't practice this, you'll end up spending time like it's a 6 marks question. Why is you supposed to just do 3 marks? So it's supposed to be something that you're doing quick. Wash his hands. Nah, that's just I just joking. I'm not under the influence of the 19. With respect to the origin, boom, the position vectors A and B are 12, 0, and 3, 6 respectively. Wow, this vectors question is intense for a CSEC student. Was my Instagram just at Cohen Springer? At Cohen Springer. The point D and E are placed on AC and OA respectively such that AD is half, so this is halfway, and OE is a quarter of the way. So one, actually not really a quarter of the way. OE is a quarter of the whole of OA. So this is one of the more confusing things for students. So AD is half of AC. So yes, this is 1, 2. But if you said that OE is a quarter of OA, what does that mean? All right, so it's a quarter of OA. So that's safe, you're safe. So this is a quarter of that, so it means yes, it's a quarter of the way through. But like if this is, you have to be careful. Like if this is a quarter of E to A, then it's actually 1/5 you're dealing with. Think about it. Just think about what I just said, right? And that comes. So express the following vectors in the form A, B. Let's see what's the first thing they want us to express. AC. So from A to C, kind of free marks thing is this. So from A to C, we could just watch this and put it, right? A to C, it just went up 6. It didn't go across any. So it's 0, 6. I mean, you could be extra and work it out and all kind of thing. Say A to C is the same as A to O, then O to C. And the usual triangle law, A to C is the same as O to C. How we say? O to C minus the O to A. So it's the same as 12, 6 minus 12, 0. And you're going to get 0, 6 back again. This is the triangle law. You can look up my video on vectors, triangle law. So you can do that working as well. Well done, Dinell. So Dinell has it. You could do that working as well. But you can watch this and see it just went up 6. OD. How are we going to find OD now? O to D. Well, O to D is a combination of O to A, and then we left A and we went to D. No, keep it in mind that A to D is the same as half of A to C, which we just found. Half of 0, 6, which is divide everything, you get 0, 3. So therefore, O to D is the same as O to A, which is 12, 0 plus 0, 3. So we had some mistakes. Ariane, that's your first mistake there. So it's going to be 12 to 3. Because remember, you're going halfway. Bar T, mistake. So it's 12, 3. So O to D is not the same as O to C. O to D, you need to go the OA, and then you need to go the AD. So the answer is 12, 3. And the last vector that they want us to find out is BE. B to E. And that's it. We've done the paper. We'll be going on into sample exam 2, which I hope to do tomorrow, please God. So B to E, kind of free maths thing is this way. Wait. We can't assume that it didn't move on the X. We need to make sure. We can't really assume that, right? Not so? Because we don't know if this is supposed to line up. Nowhere said that must line up. We don't know. I'm streaming for the last hour and 11 minutes, and I'm going to finish now. So we want to go from B to E. And seeing the known routes we could go, we can say B to E is the same as B to O, which we know, plus, it's just the reverse of that, plus O to E. We know what O to E is. O to E is equal to half, well, not a half, a quarter of O to A. So this is a quarter of the 12, 0. So this is 3, 0. So this little part here is like 3, 0. And if we need to go down this will be like -3, -6, okay? So B to E is -3, -6, plus 3, 0. Let me see if anybody has the answer yet. So it really didn't move. So it's 0, -6. You understand? It didn't move anywhere on the X. It just went down 6. So 0, -6 turned out to be the answer. Well, then Aquino, I think you're the first one to put the answer. So close off the live chat before you pop back on. Close off the live chat. Press like on the video so it will go out to more people. I think I didn't talk that much and I just kind of run through the questions effectively here, and I left some good tidbits in. Some of these questions were challenging. This is the page, those of you who are asking, my Instagram handle at Kerwin Springer, just my name, Kerwin Springer, and you'd be able to follow. This is the, if any of you all in Form 4 or you know the subjects you're going to do in Law 6 and you want additional lessons, this is the best lessons in the Caribbean. You understand? Online lessons, high quality, paid online, SCA, Law School, CSEC, Cape, and y'all, we have some very exciting stuff coming up. And we always have giveaways and all kind of thing, that kind of thing. Right now, the students from last year have the chance to win 2 iPhones 12. So, but we have some exciting classes coming up as well that I will unveil probably next week. Extra curricular classes, like I will unveil it next week. I don't want to say, but you see this link, click this link and it will take you to the promised land, which is the Student Hub Discord that has 14,200 members in it. And you would see, let's just accept the invite and see what's going on. You will see the Student Hub channel, which has all, I don't know if you've seen any corner here, CSEC Maths, CSEC Ad Maths, English, all the CSEC subjects, past papers that you could want are inside here. There are students inside here talking about different exams, this, that, the other. It's useful, especially if you didn't really get no lessons during the thing, maybe financial issues, you can afford lessons. Jump in here and make use of that, bro. You just need to put in more work. You're not somebody spoon feeding you or anything or guiding you. But you could still, you're not no excuse. You could still come here and check through and learn things. And there are even channels and groups that people make out of this last year for different subjects. And they're making back this year. Anyhow, so that's enough talk. That's enough long talk. Love and blessings always. Press like, do what you had to do. Check me out on Instagram, ting, till we meet again.